Hi, my name is Joseph. I'm a rising senior in biomedical engineering. For the summer, I've been working with Professor Haldar on MRI reconstruction. Research is integral to the ongoing advancement of technology and the sciences. I have found that research provides me with a real-world application for the material that I have learned. First, unlike simpler modalities like X-ray, magnetic resonance imaging must be processed. The MR scanner acquires K-space and then takes the inverse Fourier transform to find the image that radiologists look at. However, in some applications like pediatric MRI and dynamic MRI, we need to acquire an image quickly, and to do this, we undersample K-space and use a reconstruction scheme to estimate the image. The goal of this research is to define what kind of data can be used to prove the clinical accuracy of a reconstruction scheme. These are my results. Here you can see the original image and the Fourier space associated with it. Next, after the magnitude of the image was computed, after the JPEG compression was performed, after the image was interpolated, after the skull was stripped, after coil bias correction was applied. You can see that all of these images have unique patterns associated with them and don't reflect the true nature of K-space. Magnitude tends to impose symmetrical constraints. JPEG compression deflates the rank of the S matrix. Interpolation reduces the peripheral coefficients. Skull stripping and coil bias correction totally changes the organization of K-space. On the left is an undersampled reconstruction of K-space data acquired on an MRI. On the right is the reconstruction of a JPEG image. They both have an acceleration factor of 1.75. As you can see, the reconstruction problem posed by the JPEG image is significantly simpler than the actual reconstruction problem. The difference seen is due to JPEG compression and the lack of phase in the JPEG image. Therefore, we argue that using acquired K-space is integral to showing the effectiveness of a new reconstruction method. This is what worked for me and what didn't, and this is where I think this particular research is going.